Hi there, everyone. So, what we're going to do today is to calculate the equivalent resistance of a circuit. This is extremely useful, especially at the very beginning, because when you have a circuit, it's going to be easier to deal with it if we calculate and find an equivalent resistance, which basically means that we're not going to have to find and calculate each and every resistance and take care of that because we're going to use only one single resistance, which is going to be as if we were counting them all by using the relationship within the resistances. So what we're going to do right now is find the equivalent resistance of a circuit. So this one is going to be our circuit. So if we have a resistance here and then one here and also one here, like so, and we're going to have the power supply here, like so. Okay, so this resistance here is our R1, it's 180 ohm. This resistance here is our R2, it's 160 ohm. And this resistance here at the very top is R3, which is 60 ohm. This is our power supply, so V1, and the voltage is 9 volts. So what I want to find out is the equivalent resistance here, which we're going to call REQ, like so. Right, so to calculate and find out the equivalent resistance, what we're going to do is say, okay, the equivalent resistance is, in this case, R3 plus R2 in parallel with R1, because those two are in parallel. So we're going to say R3 plus R2 parallel to R1. Now, what does parallel mean? Well, parallel basically means that we are gonna have to multiply the two values and divide by the sum of those two values. So what it means that REQ, so our equivalent is going to be R3, so 60 ohm, 60 plus R2 in parallel with R1, so R2, which is 160 times 180, so 160 times 180 over 160 plus 180, so 160 plus 180, just like that. So now just a matter of calculating it. So REQ is equal to 60 plus 160 times 180 is 28,800. It's 28,800 over 160 plus 180 is 340. So now again, we're gonna compute this. So we're gonna have long fraction with 340. 6 is 20,400 plus 28,800. 28,800. And the equivalent resistance at the end of this, well, I'm not there yet. So those two, if I sum those two. So 20,400 plus 28,800 is 49,200 divided by 340. And now I'm gonna have to use the calculator because I'm not able to do that. But yeah, our equivalent is roughly 144.11. I really have to use the calculator. 0.71. I knew I wasn't gonna do that. Okay, so and this is our final answer. So essentially, if you have a circuit like this one, and you don't want to take account each individual resistance like R3, R2, and R1, you can find the equivalent resistance, and the equivalent resistance is found this way, and you can use it to basically say, okay, screw this circuit, I'm just going to use the equivalent resistance and it's going to be easier rather than dealing with three individual resistances. So this might seem pretty straightforward and silly to you in a simple circuit like this one, but it's going to be extremely useful going forward. And I'm going to show you some more examples later.